Hey guys, I thought I'd try something new as I'm doing these Google Forms for homework and still kind of working out how I want it to look. So um, this might seem like it's a little bit delayed. So that's what I'm going to try to do better on. But based on the responses I got from those of you that filled out the form, and thank you to those of you who filled out the form, I wanted to go over just problems 7, 8, and 9. Now, this is actually from Wednesday's homework, not yesterday's homework. Okay, so I know it's a little confusing, but this is from Wednesday's homework. Um, the answer key to yesterday's homework, which is the review worksheet for 8.1 to 8.3, is posted on the Google form for today, and today is Friday. Okay, so bear with me a little bit as I kind of work through this new process and figure out what makes sense um, for all of us. Okay, so again, based on the responses, it seemed like the most support was for 7, 8, and 9. So let's look at 7 here. So the question itself is saying find vertical asymptotes, holes, and horizontal asymptotes for the graph of each rational function. So the first step is to always factor if possible. Okay, and I'm going to write a note here. This is not factorable. You don't have to write that, but I'm just letting you know it's not factorable, so I can't do anything with it. Okay, and then I always want to find the whole first. Okay, well, a whole occurs when there's a common factor in the numerator and denominator. And since there's no common factors, there's no holes. So I'm going to say no common factors in top and bottom, which means no holes. Oops. Okay. Vertical asymptote. Vertical asymptote you do by setting the denominator equal to 0. So let me just do this to help out a little bit. So vertical asymptote, set denominator equal to 0. And this is after you cancel out any common factors. So that's why I always want you to start with the whole first, because if it is a common factor, then it's a whole. Once it's a whole, it's no longer a vertical asymptote. Okay? But since there were no common factors, now we just set the denominator, 3x plus 2 equal to 0, and then solve for x. So x is going to be negative 2 over 3. So that's where your vertical asymptote is. Now, the horizontal asymptote, this is where we have to use our rules. Okay, this is where we have to use our rules comparing P and Q. So P, which is the degree of the numerator, is 1, because it's 4x to the 1. And Q, which is the degree of the denominator, is also 1. Well, so this means that P is equal to Q. When this happens, you look at the leading coefficient of P and divide that by the leading coefficient of Q. The leading coefficient of the numerator, which is P, is 4. The leading coefficient denominator is 3. So your horizontal asymptote is going to be at y is equal to 4 over 3. Okay, moving on. Number 8. These are our answers here, and I'll kind of just show you how I get all of these. Okay. So first off, this is already factored for you, and there's no, actually, let me just erase these so I can kind of start from the beginning here. There's no common factors, and so therefore there's no hole. So right away down here, I'm going to put holes, I'm going to put none. Okay, so I do the hole first, and then I look at the asymptote. So to find the vertical asymptote, I look at this, set these equal to 0, the denominator. And you get 1 and 5. So your vertical asymptote is going to be at x equals 1, and another one at x equals 5. Your horizontal asymptote, you got to look at P and Q. Okay, so I'm going to put this right here. P is equal to 1, the degree of the top. Q is equal to 2 because it's x squared, which means that P is less than Q. So your rule if P is less than Q, then the horizontal asymptote is going to be at y is equal to 0. Okay, now let's go ahead and find our x and y intercept. These are kind of just how we've always been able to find them. X-intercept is when y equals 0. So set y equal to 0. If you multiply both sides by x plus 1, x minus 5, it just ends up being 0 is equal to x plus 3. So therefore, x is equal to negative 3. So your y-intercept, your x-intercept is going to be at negative 3, 0. However, take a look. It cannot be there because of this horizontal asymptote. So actually, there is no x-intercept. Okay, and that's kind of a weird thing and a hard thing to remember to look at. But the reason why it can't be there is that there is a horizontal asymptote at 0. Therefore, you can't have an intercept there. Okay, the y-intercept, this is when x equals 0. So set all your x's equal to 0 and solve for y. You're going to get 3 divided by 5. So your y-intercept is at 0, 3/5. Okay, and then domain and range. You're going to start with all real numbers where x cannot equal, so the domain is tied to any holes and your vertical asymptote. So there's no holes, but there are asymptotes at 1 and 5. Whereas your range is tied to your horizontal asymptote, so all real numbers where y does not equal 0. Okay, so to graph this, let's go ahead and draw in. I always start with the asymptotes first. So at 1 and 5, and then at y equals 0. Yes, and so this is something I want to point out. A lot of you guys ask, what do you do if there's 2 vertical asymptotes? Well, you work with them, meaning you draw both in, okay? So now to find points, and I'm going to tell you guys, I wouldn't stress out about the graphing as much, like the specific find points for the graph. But here's what I would do. I would pick 2 points basically on this side, 2 points between them, and 2 points over here. Okay, that way you hit all the branches. So if my vertical asymptote is at 1, I'm going to pick -1 and 0. And then I'm going to pick 2 points on the other side. So how about 2 and 3? And then I have another asymptote at 5, so I can pick 4 and 6. And I'm just going to plug it in, and for sake of time, I'm just going to tell you the answers. But again, I'd be plugging these x values in over here. You get 1/6, 3/5, -5/3, -3/2, -7/3, and 9/5. So you can see sometimes the numbers aren't nice, and that's okay. All right, but let's just graph this based on what we can. It's going to look something like, see if any of these numbers look good. -1, 1/6 is about right here. Okay, so you just have a branch that goes like this. And then 2, -5/3. -1/2. So then your middle branch is kind of like this. And then over here, and there you go. Again, I would not worry you guys so much about the actual points on the quiz. I'm not going to have you graph. All right, you would have to find all the key data points like the x-intercept, the y-intercept, etc. But I won't have you actually graph it. Okay, finally, let's look at number 9. Okay, so first step again, when dealing with a rational function, is to factor. So this is going to become, top stays the same. The bottom is going to factor into x plus 4, x minus 2. And now we have a common factor. So because we have that common factor, that becomes our whole. So we set that equal to 0, and we get a whole at x equals 4. I'm sorry, -4. Now, some of you guys were asking about the y value of it. I'm not concerned about that. I'm not going to ask you for that. But if you were to find the y value, you would take this -4 and you plug it into that the simplified expression. So after you canceled out. Okay, so in this case, you'd probably get y is equal to 1 over -6. Okay, but don't worry about that for now. So now your vertical asymptote is going to be what's left in the denominator. Okay, so we set this equal to 0. You get a vertical asymptote of 2. Okay, and then for the horizontal asymptote, you compare P and Q. The degree of P is 1 because it's just a single x. The degree of Q is 2. So I'm going to follow the same pattern between P is less than Q, which means that the horizontal asymptote is going to be at y equals 0. So similar to the one above. Okay, let's go ahead and find our x-intercept and y-intercept. So x-intercept again is when y equals 0. So I'm just going to take, you get 0 is equal to x plus 4 divided by x squared plus 2x minus 8. You're going to get 0 is equal to x plus 4. So x is equal to -4. So this would be -4, 0. However, again, this is actually going to mean none because if you look at your horizontal asymptote, there's no point where y is going to be 0. So turns out there's actually no x-intercept. All right, and you might catch that before you do the work, and that's great as well. All right, y-intercept. This is when x equals 0. So plug in 0 for every x in the original expression. Oops. And you're going to get 4 over -8, so -1/2. So y-intercept is at 0, -1/2. Okay, domain is going to be all real numbers except x cannot equal, and then remember again, domain is tied to vertical asymptote in wholes, so it cannot equal 2 or -4. Range is tied to horizontal asymptote, so it's going to be all real numbers except your horizontal asymptote, which is 0. Go ahead and draw this in. So we have a vertical asymptote 2 and a horizontal asymptote y equals 0. And then I would just choose values. And this time I'm just going to choose a couple on the left side of the vertical asymptote and a couple on the right side of the vertical asymptote. So I'll choose -1, 0, and 1. And then I'll choose 3, 4, and 5. And I'm going to get -1/3, -1/2, -1, 1, 1/2, 1/3. So and I know that there's a hole right around here. So it would look like this and come down. And then on the right side, should have done it as a different color. And there we go. So again, if you are graphing, you want to pick points on both sides of the vertical asymptotes. All right, guys, I hope that was helpful. Email me with any more questions. Thanks. Bye.